doing these. Okay, so page 42, question 15. So let's write that one there. Page 42, question 15. So the question says, A, given 9 squared equals 3 to the n, write down the value of n. And then B, solve these simultaneous equations. Solve the simultaneous equations 3x plus y. What we're doing, the people who've just come in, we're just doing a little bit of revision. Okay, so we're doing the extra revision that wasn't, that I haven't recorded for YouTube already. So this is being done now. 3x plus y is 9 squared. And the second one, 4x minus 2y equals 8 to the 4. Okay. Okay, right, so the answers to this, I'll do these in a different colour. Right, so A. If you've got 9 squared is 3 to the power n, and it says write down the value of n. Okay, so we've got a 9 to a power on the left and 3 to a power on the right. Okay, we can simplify these powers once we've got these as the same. If it was a 9 and a 9 there, or a 3 and a 3 there. And what we're going to do is make this a 3. So we can say 9 is 3 squared. Okay, so now we've got 3 squared is 3 to the n. Does that make sense? Because that's a 9 in that. 3 squared is 9, not 9 there. 9 squared is 3 to the n. Does that make sense? 3 squared is 9, and that side stays the same. So when we expand here, what we do is you multiply there. So 3 to the power 4 is 3 to the power n, because that's 2 times 2. Okay, so therefore we can say n equals 4, like so. Does that make sense? And these you can always check on your calculator. The check for a question like this would be 9 squared on your calculator, you might know, is 81. And then on the right-hand side, 3 to the power 4 now, because n is 4, is actually 81. So because they're the same, we can be happy there. Okay, so there's the check. Any questions about that? Think you can do that one? Right, so the next one, part B. Any questions? No. Okay, so this is the start of the revision for people who've just come in. So we've got 3 to the power x plus y is 9 squared. Okay, and the other ones, these are simultaneous equations. 4 to the power x minus 2y is 8 to the power 4. Okay, that's what we've been given. We've got to work out the x and the y without trial and error. Okay, so this first one here, we've already just worked out that we can say, so from part A, we can have 3 to the power x plus y. 9 squared, look, here is 81, and which is also 3 to the power 4 is 81. So that is 3 to the power 4. So we can replace that 9 squared with 3 to the power 4. Okay, so if we call that equation 1, from equation 1, we're going to have x plus y equals 4. And that's a little bit nicer to look at than that one. Okay, so for this second one, we need to know what 8 to the power 4 is. And then hopefully, and it does seem, because there's a lot of 4s going on there, that will be a power of 4. So 8 to the power 4, well, 8 squared we know is 64. So 8 to the power 4 is 8 squared. This is doing it in your head, but obviously you can do it in your calculators. So it's 64 times 64. Actually, you could do this without a calculator. You might know that 64 is 4 cubed. So it's 4 cubed times 4 cubed. So it's actually 4 to the power 6. But if you was doing it on your calculator because you didn't know the answer, you'd have to start off by working out that 8 to the power 4 is whatever 64 times 64 is. I'll get my calculator out, that's all. Right, so 8 to the power 4 is 64 times 64, 4,096. Okay, and what you do then is, so I've just done that so far on my calculator. It doesn't work with that brightness behind it, does it? I'll just move that to one side there. I've just done 64 times 64, which is 8 squared times x squared. So now if we do log to the base 4 of answer, because we want to know what power of 4 makes the answer, and it comes up with 6. Okay, so back to this way, you could say log to the base 4 of 4,096 is 6. Okay, so this we can say therefore 4x minus 2y is actually the same as 4 to the power 6. So the way that I've done that, the quick route for doing that, work out that on your calculator. You can do 8 to the power 4 on your calculator. And then, because we want a base 4, do log to the base 4 of answer, and it'll come up with 6. And that's how you can put that together there. So we call that equation 2. We actually get, people who've come in a little bit late, we're just starting the revision with the extra stuff. I've worked out extra questions that I haven't done yet on YouTube. And this is the start of your revision. So if you can do these, you'll be doing really well. Because these are on the next pages, so they're a bit harder. Okay, so we get x minus 2y then is, but we'll just take out the powers here on this one. So it's x minus 2y is 6. There, it was that is equals to that. Is equals to 6. Okay, so that's equation 1, gives us this. Equation 2 gives us this. If we do this equation, take away this equation, okay, so if we do a take away here, x take away x cancels, y take away 2y makes 3y, and then y take away minus 2y makes 3y, 4 take away 6 is minus 2. So therefore y is, divide both sides by 3, minus 2/3. Okay. It's looking, have I made anybody spotted any mistakes? Do you feel I'm okay so far? It's just that fraction is making me feel a little bit, we'll do a final check at the end. And then, if we substitute for y in this star, this first one here, we've got x plus y equals 4. So x minus 2/3 is 4. So therefore x is, oops, just going off the page there, 4 2/3. Okay, so I'm just going to highlight these as final answers, and then I'm going to go back and check them. So that was one answer, and that's the other answer there. Okay, so our final check is to put them into the original. I'll just do the check down here. Oops, not like that, that won't work. Right, so the check, if you've got 3 to the power x plus y, has to be 9 squared. That was that first equation up there, look. And also 4 to the power x minus 2y, 4 to the power x minus 2y has to be equals to 8 to the power 4. Okay, so I'm going to put this to one side. 3 to the power x plus y, 3 to the power, turn that off there. Doesn't make much difference. Right, 3 to the power x plus y. X is 4 2/3, which you can use that there. 4 2/3. and then plus y, which was minus 2/3, so plus minus 2/3, that is 81. Can you see that there? And the answer that it was supposed to be was 9 squared, which is 81. So I'm happy with that one. And then clear, and then 4 to the power, and it's x minus 2y. So again, it's 4 and 2/3 minus 2 times minus 2/3. 4096, and 8 to the power 4. I just remember this anyway, but just in case you forget, whoops. 8 to the power 4, 4096. So I'm happy. Okay, so even though it came up with fractions, the fractions cancelled out here in the mix here. So that's why it was okay in the end. Okay, so that's the first bit of revision that you need to do. So we've done that one there. Okay, these are 4 questions that I've just looked at your what you need to know for your exam, and these 4 questions are very helpful. So you've done yourselves a big favour by coming this afternoon. So, any questions about that first one? It's being panoptoed and YouTubed at the moment, so it'll be up later. Then I've done my duties for you this term because I'm a bit overloaded. Right, so the next one, page 68, question 14, in a good way.
So where can we find those questions?
In textbook, page 68, question 14. Here, somebody lent it to me. I worked it all out and forgot to bring my book. So page 68, question 14. And then all the other stuff on YouTube's now in a playlist. So page 68, question 14. So I'll write out the questions for you and the answers. And then these will be the harder ones actually, because they're on the second pages. Given that both x minus 1 and x plus 3 are factors of ax cubed. Oops. So I know they're like cubics in the first year, so that's why I would have put one of these in. Bx squared minus 16x plus 15. The first thing is find a and b. The second thing we need to do, fully factorise. I'm just going to call that f of x, because then fully factorise f of x. So instead of writing it out again, I can just put that, and it's useful in a bit. C, sketch the graph of f of x. The question's written it all out, but I haven't. And D is solve the inequality. Now, there's a lot of marks in this one. F of x greater than or equals to 0. I don't think I would have put that many marks in one question. But this is 9, 10, 11, 12, 13, 14. There's only 20 marks in one question, so it'll be bits of this, not all of this. So you're getting the full picture. But make sure you can understand it. Okay, so this is more than enough. I'm not just giving you exactly what you need, a little bit more, so that you learn a bit more. Okay, but not too much. Right, okay. So for part A, let me change the colour again. Right, if we find A and B. Now, if it says x minus 1 and x plus 3 are factors of this, so that means, do you remember with the factor theorem? Say if x minus A is a factor, then f of A equals 0. Okay, so if you've got x minus A as a factor, then the number, look, with a change of sign, so that's minus A there, and this is plus A here. So it's the number with a change of sign is equals to 0 when you substitute it into this equation here. So we can start off. So we've got x minus 1 here is a factor. So f of 1 equals 0. Okay, and this is the factor theorem. We did it a long time ago. F of 1 equals 0, and f of, for this one here, look, minus 3, because we've got plus 3 there. F of minus 3 is 0. Okay, So we can put x is 1 in here and put a note there. And then put x is minus 1 in here and it's equals to 0. Then we'll get simultaneous equations for a and b. And we can solve the simultaneous equations, then we know what the cubic is. Okay, so first of all, let's substitute x equals 1 and we get a. Now when it's 1, that's 1 cubed is 1, 1 squared is 1 and 1 is 1. So you get all these, it's going to be a plus b minus 16 plus 15 is 0. Okay, so you get a plus b minus 16 plus 15 is 0. Okay, so that's a straightforward one. So we can have, therefore, a plus b, and then we've got minus 1 here, because minus 16 plus 15 is minus 1, is 0. So a plus b is plus 1. And that's going to be our first equation in our simultaneous equation. Okay, just colour that in so that stands out. And then we've got to substitute x is minus 3 in here. So it's a times minus 3 cubed. So when we've got a and it's minus 3 cubed, make sure you put the minuses and the brackets. Minus inside a bracket if you do this on your calculator, because otherwise your calculator will get some of them wrong. B times minus, well, it won't get it wrong, it just doesn't interpret what you want it to interpret. Minus 16 times minus 3 plus 15 is 0. Now minus 3 cubed is minus 27. If you, the calculator will get the odd powers right, whether you put the brackets in or not. But this one, if you just type in minus 3 squared, it will do the 3 squared, because from BODMAS it does the power first, and then applies the minus afterwards. So minus 3 squared is actually plus 9, but if you don't put the brackets in, it will come up as minus 9. So anyway, so that's going to be plus 9b. So it's either you know it, but just always put brackets around the negatives when they're raised to a power. You'll get it right. Right, minus 16 times minus 3 is plus 48. Plus 15 is 0. Let's get minus 27a plus 9b. This is 63 on the left, so it's going to be minus 63 on the right. Okay, that's our equation 2. There. Everybody happy with that one? So now we need to solve them. Oh, actually, look at all these numbers here. These, now this might not always happen in every case, but look, these will all divide by 9. So that's going to simplify that a lot. Because both sides of this equation divide by 9, we can do that. So it's going to be, if we divide by 9, minus 3a plus b is minus 7. So let's call that one number 2 instead, because that one's a bit neater. Okay, so that one's a bit easier to work with. Okay, so now if we do 1 take away 2, the b's will cancel, look, because that b, take away that b will cancel. So we'll get an equation for a's, and then we can work out the b from once we know what the a is. So if we do equation 1, take away equation 2, we've got a, take away minus 3a, so that's 4a there. B, take away b is no b, that's what we wanted. And then 1 minus 7 is 8. Actually, some calculators solve simultaneous equations as well, so check to see if yours does, or just get them right. A is 2. If 4 times 2 is 8. And then we can substitute for a in, say, 1. Doesn't matter which one. So we have 2. Instead of a here, we can write 2. So it's 2 plus b is 1. So this means that b has to be minus 1, because 2 minus 1 makes 1. 2 minus 1 equals 1. Okay, so there you go. So we've now got our equation. And I'm going to go onto a new page now. So a2b minus 1. And I'll do parts... Oh, that's just part A, find A and B. I've done that. And now I've got to fully factorise, sketch the graph and solve the inequality. Right, next page. So I'll just write this up here. We've got that. So from the work we've done already, we've got the f of x, a2, b minus 1, wasn't it? Is 2x cubed minus 1x squared minus 16x plus 15. Okay, so I've put the a there and the b there. A2, b minus 1. 2 there minus 1. So that's what's happened there. And we also know that two of the factors are... Oh, sorry, yeah. Two of the factors, thank you, are x minus 1 and x plus 3. Okay, so that's two factors. So we've got to finish factorising it, fully factorise it. So f of x, we know it's going to be x minus 1 times x plus 3. And then there's going to be there's going to be something else in here. Now, because there's a 2 there, and we haven't got a 2 in the x's already, I know that's got to be a 2x. And then there's going to be another number there, and I don't know what that is yet. Well, actually, I do, because it's got to be... that. The only way we can get the x cubes is from this x times this x times this x. So that's why that has to be 2x there. Is it x, x, and 2x, get 2x cubed. The only way to get 15 is from that times the c. These x squares and these x's, these are more complicated because they all come from different places. But the first one has to come from the first ones multiplied together, and the constant has to come from the constants multiplied together. So that's quite quick. So by observation, we can say c must be minus 5, because minus 1 times 3 times minus 5 is plus 15. Okay, so we can say f of x, this is part B, f of x is x minus 1, x plus 3, 2x minus 5. Okay. If you remember with the binomial expansion, do you remember it goes 1, 3, 3, 1 for these cubics? Well, the 1 is referring to the fact there's only one. The ones are that the x cubes come from one place only, and the constant comes from one place only. But the x squareds and the x's, they will come from 3 places each. Now, I used to have a student who could look at that and say, who could work out, even if he wasn't told these, he'd be able to work them all out by looking. It was very good. So, but you don't need to do that. I was just like, yes, right. I used to get him to check things for me. Yeah, so it is possible to do it, but he would know where the three things that went together to make the x squareds were, or where the 3 things that make the minus 16 were. Okay, so it is possible, but you don't need it. So, I mean, for instance, the x squares would be 2 x's with a constant there. That's an x squared. These 2 x's with this constant, and then these 2 x's with this constant. And that's how you put it together. So if you need a challenge, you can think about that. See if you can learn to do that in your head, but you don't have to. Okay? Anyway, so C, sketch the graph now. So it's a cubic. Okay. That's not a straight line, was it, that one? That wasn't very straight. Let's get that nice and straight. Yeah, that's better. So these are the x's, and these are the y's. Okay, so this is a cubic. On the x-axis, y is 0. On the y-axis, x is 0. X-axis, y is 0. Y-axis, x is 0. So if we put x is 0 in here, we're going to have minus 1 times 3 times minus 5. It makes that plus 15. So that means this cubic is going crossing the y-axis. X is 0 on the y-axis at 15. Okay, to make this equals to 0 here, because this is the cubic, so to make the y 0, which is the f of x, if you like, you could almost write that as for this part of the question, y, to make that naught, the values of x which make it naught are 1, from there, plus 1, minus 3, okay, and then this one here, 2.5, because 2 times 2.5 minus 5 is naught. So 2.5, which is over there. Okay, and then it's going to be of a positive coefficient of x cubed, because all the x's are positive coefficients. Positive cubics look like this. Okay, so we've got enough now to join the dots. That one, it's got to go like that. It had to be like that, really. Oh, no. Yeah, because it's got to cut that one. Yeah, so it had to be like this anyway, but that just confirms it. Okay, and that's what that looks like there. Let's rub that out. Just going to rub out, oops, rubbed out too much. Let's just draw this line in again. Okay, and then this one, come down here, below, back up, and there's the 2.5. That's the 1. Okay, so that's what it looks like. If you did it on Google, it'd probably look a bit different, but that would do for an answer. Okay, now where is this cubic greater than or equals to 0 was part D. Solve the inequality f of x, so that's the cubic, greater than or equals to 0, so that means positive. So the cubic, up here it's positive, all these it's positive, along here it's 0, and down here it's negative, because these are negative numbers down here, and these are positives, and that's the 0. Okay, so the cubic, f of x, is greater than or equals to 0. So it's positive here. Look, it's up there, positive for these values of x. So between minus 3 and plus 1. Okay, so you can say minus 3 less than or equals to x, less than or equals to 1. Okay, oops. So what happens, you see, down here, all these are more negative than minus 3, but the cubic's always going to be down here, on the negative side. Okay, so and between 1 and 2.5, it goes below the axis as well, into the negative. So the other place is x is greater than or equals to 2.5. Because on this side here, look, the cubic is in the positive part. Okay, so that's what you need to do there. Everybody happy with that one? That's cubics. Did somebody in this class ask me about cubics recently? Was it another class? Somebody asked me about cubics. I can't remember. They might not be here. But that's cubics in a nutshell. If you can do all that and understand that, then you're doing really well. You know, that's AS there. Okay, so the next one, which I've highlighted. So we've done that one. Let's turn that back to blue. Page 84, question 20 next. I'll do that on here. So it's page 84, question 20. You need this one for your exam as well. And this one says, this is trigonometry. I already know somebody didn't like trigonometry, but it does come up next year. So f of x, it says theta. I'll write it as it is in the book, but it could be x and theta can be interchangeable with these. F of x is 2 tan, I'll put theta now, haven't I? 2 tan 3 theta plus 5 sine 3 theta. Okay, and then it says find all the solutions up to f of theta equals 0 in the range for theta between 0 and 180 degrees. So the way it's worded, in the range 0 is less than or equals to theta is less than or equals to 180 degrees. Okay. Right. Okay. So the answer to this one. So the answer, don't need A or B, it's already there. Right, I'm going to start by, when you've got it's not just a straightforward x or a theta there, it's a multiple of x, or if it's a multiple of x plus or minus some degrees, the best start for this is to say, let 3 theta be equals to x, first of all, okay? And then we can say the problem becomes f of theta is 2 tan of x plus 5 sine of x, okay? And now look, the theta has been multiplied by 3. So these are thetas as well, because this is all in thetas, but the thetas need multiplying by 3 when we work with x's, so we've got to multiply these by 3 as well. And if there was plus or minus a bit in there, we'd also multiply by 3, then plus or minus a bit. But anyway, so we can say 0 is less than or equals to x now is less than or equals to 540 degrees. Okay? And we want to solve it for f of x equals, f of theta, but I've turned it to x's now, so it's going to be f of equals 0. Okay, so we can say 2 tan x plus 5 sine x equals 0. And then we'll go back and change it into thetas at the end. Right, so the first thing to see here is, think. I'm going to turn tan x into sine x over cos x, because that was one of the, there's two that you need to learn at AS, two trigonometric identities. They're important. Sine squared theta, or x, plus cos squared theta is always 1. And tan theta, sometimes there's brackets there, is sine theta over cos theta. And these come from Pythagoras and right-angled trigonometry, but using sine and cosine for the sides instead of ABC, like we had before. Okay. So if we change this now, this is going to be 2 sine x over cos x for the tangent one, plus 5 sine x equals 0. And what we can do with these, we've got two things here. They will factorise because we've got a sine x in each of them. Okay, so we'll take a sine x outside the bracket. So it's going to be 2. And then this is 2, because that is 2 times sine x divided by cos x. You can say this is 2 over cos x. You can write that like that. And then this is going to be plus 5 equals 0. Everybody happy with that one? Because look, that's 2 times sine x, that's all on the top there, divided by cos x, and 5 sine x is 0. Okay, actually that should be a capital X there to match that capital X over there. Match the capital X there. Right, so we've got two things multiplied together that make 0. So either the first one makes 0 or the second thing makes 0. Okay, so you can either say, therefore, sine x equals 0, or we can say 2 over cos x plus 5 equals 0. Okay, and we've got to go from, if you remember, 0 to 540. Okay, so think about, I'll do this with the graphs way, I think. Let's think about the graph of sine x. Not very straight again. Sine x looks like this. That's 0. That's 360. We get back to the beginning again. And that will take us to 720 there. So that's more than enough because we've got to go to 540. That's 180 there. 540 is there. And we want all these values where sine x is 0. So it's all these here. Does that make sense? So it's there, look, sine x is 0 at all those places there. So this one, we're going to get x is 0, 180 degrees, 0 degrees, 360 degrees, and 540 degrees. Okay. And then this one, We need to do a bit of work on this one. First of all, take 5 from each side. So 2 over cos x is minus 5. So then we want to work out what x is. That lowercase again. Doesn't matter if you do that in an exam. I wouldn't mark and knock a point off of that. Because we want to work out what x is, we take the reciprocal of each side. So cos x over 2 is minus 1/5. Okay. Multiply both sides by 2. Cos x is minus 2/5. Okay. And it's cos x is minus 2/5 between 0 and 540. So that graph is for that one there. If I draw the cos graph down here, this is sin x here. I just draw the cos graph along here, up to 540. So there's 0, 180, 360, 540. They should be equally spaced. The cos graph, it starts at 1 and then comes down to here. Sorry, let me just do that again. It comes down to 1 there. The key point, so it's its highest at 0 and its lowest, happen every 90 degrees. 270, 360. And that's the same here, look, the highest is 90, the lowest is 270. I just didn't write them on there. So the lowest is here. So it gets up like, oh, look at that, you missed your screen. Right. Okay, so it gets to 360 there. And then we need to go to 540, which is another 180. So it's going to come down like this. Okay. Like so. Because the next low point there, 360, and that'll be 450 when you add on 90, and then 540. So as long as you start in the right place, if you remember that cos x starts at 1, and then if you draw on every 90 degrees, so it goes high to 0 to low to 0 to high again. Okay, and then the sine one, if you draw again, you've got to remember it starts at 0, then it's the same pattern, it just starts at 0 to high to 0 to low. Okay? Right, anyway, so your calculator now, we're going to make sure your calculator's in degrees for this question. And then we do shift cos inverse, and it's minus 2/5. So it's minus 0.4. 113 degrees is what it's given you there. Okay, so I'm going to zoom right in here. 113 degrees is in between 90 and 180. Look, so it's there. That's 113.6 degrees, actually, to be exact. Okay, so that's good. It's not drawn to scale, but that would be minus 0.4 if it was. So our second one is, look there. Okay, and so by the symmetry, look from there, I'll just draw this bit in a different colour. There to there is 113.6 degrees. There's a line of symmetry down there, so there to there has to be 113.6 degrees as well. Does that make sense? And then on this side here, there to there, sorry, a little bit further even. Look, this point 4 is here. So there, all the way up to there, that's 113.6 as well. So our answers for this one are, you get x is 113.6 off your calculator. The next one, which is here, is actually 360 take away 113.6. And then the last one is 360 plus 113.6. Okay, so the next one is 360 plus 113.6 degrees. Okay, so I'm just going to do these on the calculator. This one, 246.4. This one I can do in my head quickly, 473.6 degrees. Okay, so there's our x's. Does that make sense? So, but really we want thetas. So x is 3 theta. If we've got x is 3 theta, the thetas are the x's divided by 3. Okay, so the thetas are 0 divided by 3, which is 0. 180 divided by 3, which is 60. So that's that one and that one. 360 divided by 3, which is 120 degrees. 540 degrees divided by 3, which is 180 degrees. And then these answers divided by 3 as well. 113.6 divided by 3. 37.9 degrees. And the next one, 246.4 divided by 3. 82.1 degrees. And then the last one, 473.6 divided by 3. 157.9 degrees. Okay, so there are our answers there at the end. So there's quite a lot in that question there. Okay, but you wouldn't have to talk it through so much. Is everybody happy with that one? Well, you'd have to watch it again, I guess, and make sure that you're really happy with it. Right, I've got one more question to do, and it's not as long as all the others. So we've done that one now. Page 152, question 18. Nice and quick one, this one is, so I can do it in 5 minutes. Right, so it's page 152. Question 18. And it says, find the rate of change of the function f of t equals e to the 2t at time t is 1.5. So that's the question that we need to do. And also, I've made a note, you need to make sure you can sketch the graph of f of t and then identify the intercepts. So that's a little bit extra that's not in the question there. Okay, right, so this is nice and quick. The reason being, if you remember, if you've got f of t is e to the 2t, the gradient function, or in general, f of t is e to the kt, f dashed of t is k e to the kt. Okay, so does that make sense? So at the gradient function, which is the rate of change here? The rate of change is this here. That's what you've got to do, this, apply this formula to it. So f dashed of t is 2 e to the 2t. Okay, and then if you want f dashed of t, or f dashed of 1.5, because it's at time t, 1.5, look there, so we substitute the 1.5 in there. F dashed of 1.5, I've written that twice now, is 2 e to the 2 times 1.5, if you like, so that's 2e cubed, because 2 times 1.5 is 3. So on the calculator, we've got to go 2 times shift e, up there, I don't know if you can see it very well there, and then, 2 shift e cubed, that's what I've got there, 40.2. So just put down the sensible 40.2 rate of change, units per second or whatever it is. Just the number will do. So that's the first bit of the answer there. And then the sketch the graph, which Right, so e to the n power, e to any power always looks like this. Okay, so you just do that. And then the only axis that it changes is, it crosses, is the y-axis, because it will never go below it never goes below the x-axis. And whatever value, even though it's like e to the 2t, it's always, that's going to be e to the 0 is always 1 there. Okay, so knowing that that's always 1 is an important thing to remember. Okay, so that's the first bit of your revision. That's the hardest bit of your revision. Okay, on Monday we'll start revision again. We'll go right back to the beginning. I'll pick some exercises to do. People said they wanted to do some exercises in the lecture. So that, I will try and do that on Monday. I'll pick some sensible ones. So if you bring I'll bring a textbook. Or you could bring it, if you bring your textbook, and I'll give you which exercises I want you to do. And we can talk about it as a group. Okay? So I'll upload this to, it's on Panopto and it will be on YouTube. So I feel my job is done for you. For the time being. My YouTube job is done. There was nothing that, it was just that cubic. That cubic, I thought if it doesn't factorise nicely, could be wrong. Okay, so we've got the drop-in now. If you need to come, Aaron, are you on your way?
Not today, I'm afraid.